of cards has 52 cards. 13 of these cards are spades. How probable is it that we draw a spade from the deck? We might say we have 13 chances out of 52. Now, in all cases, the outcomes are unknown. But what is different about these three cases?
Well, the student who took the exam is making a prediction based on her experience on how she felt she was taking the exam.
Yes, given all the evidence available, she made a personal assessment. In probability, this is what we call the subjective or personalistic approach. So, can you guess why it's best to use this approach?
I think it is used best when the person making the assessment sees that there is only one opportunity for the event to occur, and it will either occur or not occur at the moment.
And can you think of some examples, Mike?
Doctors would probably use a subjective approach if they were trying to see a patient's chances of surviving a tricky operation.
For an expectant mother, if she doesn't use any sophisticated equipment, would rely on her past experiences giving birth to determine if her child is a boy or a girl.
Wait, I just realized something. Because I felt like I didn't do well in my audition, I thought that the probability of my getting the lead role is low. I based the probability on a personal judgment. I used the subjective approach.
That's right, Sandra. Now, what did you notice about the second example?
Well, the balut vendor made an assessment based on observation.
An observation of how frequently people bought balut from him. Because he observed that repeatedly, 2 out of 5 people would buy balut from him, he made the conclusion that of the next 5 people that passes by, 2 will buy balut from him as well.
Can you express his observations in numerical value?
Yes, 2 out of 5 bought balut from him. We can express that as a fraction 2 over 5.
Or we can express it as the decimal point 4.
The balut vendor used the empirical approach, which we also call the relative frequency approach. We can define this approach as the proportion of time a particular outcome occurs in a very large number of observations. It is the relative frequency of an event in past occurrences.
I can think of an example. Let's say that out of every 100 students, only one has managed to keep a perfect attendance record throughout the whole year. We can say then that if we randomly choose a student, there is a 1 out of 100 chances, or 0.01, that she has a perfect attendance record.
Which reminds me, in my previous performances in my basketball games, I've had a field goal percentage of 80%.
We can say 80% or 0.8 or 8 out of 10.
Mike, that means tomorrow, out of 10 shots you attempt, 8 of them will probably be good and go through the hoop.
That's right!
Mr. Villarreal, what about the last example?
It helps if we first define some terms for us to understand the third approach to probability. Let's take a look at the coin again. I want to find out if the coin will come up heads or tails. When I perform this test, I am performing what we call an experiment. An experiment is an activity which can be done repeatedly under similar conditions and which can result in an outcome. Now, there are two possibilities.
The possibility of either getting a head or a tail.
And we denote these possibilities as H, T. This is what we call the sample space. A sample space is a set of all possible outcomes of an experiment. Each particular outcome is what we call a sample point. In the sample space HT, there are two sample points, H and T. Now, let's take a look at this die. What do you think would be the sample space of this die?
Well, this sample space would have 6 sample points. 1 dot, 2 dots, 3 dots, 4 dots, 5 dots, and 6 dots.
So the sample space would be